I'm David Walt, co-chair, along with my colleague Maxine Savitz, Maxine, in the front row there, of this NSF-sponsored study, of which today's symposium is part. First of all, I'd like to thank all the participants, not only for your attendance today, but also for your forbearance with the January storm. So I'm glad we could all reschedule and be here today. On behalf of the National Academy of Engineering and the Academy's National Materials and Manufacturing Board, we'd like to welcome you to this event. NSF's engineering research centers have now been in operation for 30 years. Looking forward, NSF has charged us with articulating a vision of what an NSF-supported center-based engineering research should look like in the next 30 years. Our purpose today is to hear not only the perspectives of distinguished speakers from government, academia, and industry, but also to hear your ideas, and that's really the purpose of the day. The agenda has ample time for you to express your thoughts in small breakout groups following the speaker panels that we'll have this morning as well as this afternoon, and to vote as a group on what you think are the best ideas. As the day progresses, you will engage in a variety of activities aimed at obtaining your input, and we'd really like and value your input. A summary of this symposium will be written up by a rapporteur and will be published as a separate Academy's report in about 6 months, and then a final report of the study will be delivered roughly a year from now after it goes through the normal Academy review process. So with that, let me introduce our first speaker, Dr. France Cordova, Director of National Science Foundation, to get us started in the right direction. Dr. Cordova is Director of the National Science Foundation. She served as President of Purdue University from 2007 to 2012 and earned her PhD in physics from Caltech. She's taken a personal interest in this study, and we're delighted to hear her thoughts as we get underway. Dr. Cordova. Thank you.
Good morning, everyone. I'm really pleased to be the warm-up act for this wonderful meeting. And it's about time we all got together. We're sorry about the blizzard in January on many accounts. It was a great deal of fun to be in it and be sequestered in our homes and condos for almost a week. So that was an interesting experience. But now it's time to really figure out what we're doing here with our engineering research centers. You could wonder, what's the problem? They're wonderful. We've had 30 amazing years, and now we have some new centers. I see some new center directors here. But we want to always, as an agency that's sponsoring these centers, we want to make sure that they're flexible and adaptable. They evolve with the times, and they feel current. They're serving the needs of our students and our faculty, and most importantly, they're serving the needs of our country to remain a global leader. So I'm going to make a few formal remarks to welcome you all to that theme. And as David said, this is really an opportunity for the wider community beyond the panel members that have already met a number of times and put a lot of thought to this, to give us your best ideas. So I learn more and more about engineers with every position I have, from being at NASA as chief scientist and as a scientist and working very closely with the engineers. And I know that you don't get a mission launched unless you have the science as a driver together with the best engineering thinking about concepts and designs and implementation, and working just hand in glove so that it's a really seamless team. So as you think about your concepts, and David enjoined you to to put on the table in these breakout groups and the open meetings your wonderful thoughts, ideas, observations about the centers, about what they can be. That you always you think like engineers. You think to how can this lead to a proof of concept? What does the design look like? If I really wanted this to happen, what would I need to change about the concepts of a center, about what we do in the centers, what is it that we're funding, that would make it really different, that would make your idea of where we should be headed, make that realizable. So I think that's the goal here today. As you can see from the funding we're giving to the National Academy of Engineering to do this study, that we are we're very engaged in the outcome, and we want to make the changes that the times demand. And I want to really salute Pramod Karganagar. Will you just give a wave there? I think everybody knows who Pramod is, who has come up with this concept. It was Pramod's idea that we needed revitalization of the engineering research centers and wanted that to be one of his legacies. Now, it's also an opportunity to publicly thank, and I'll have other opportunities, Pramod for just being a terrific leader of our engineering enterprise. So let me thank also Maxine Savitz and David for their energetic and dedicated leadership of this work. And I hope I've expressed more informally, just to start with, just how very important we see this. So thank you so much. I know what it is to lead an effort like this. Your disciplined approach has been and will continue to be critical in keeping us on track. I want to thank the National Research Council overall for conducting this study, and also for all the studies that it do, which are always of the very highest quality, and it's so important. I don't need to tell this group the imprimatur of the National Academy. And I think this kind of a study is going, when you produce your outcomes, is going to gain a lot of visibility, a lot of traction, because what you're also doing, and again, as engineers, is it's not just about the engineering research centers. I think there'll be elements of this that are translatable to the ideas of centers in general, other centers that NSF does, but also centers that other agencies do. So good luck with that big goal. As David told you, I served as president of Purdue University and also as chancellor of the University of California at Riverside. And at our universities like Purdue, we have these engineering research centers that we really value. At Purdue, we had two outstanding such centers. One was called the Center for Structured Organic Particulate Systems, and the other, the Center for Compact and Efficient Fluid Power. And I was very impressed with the innovations and entrepreneurism that came out of those centers. I also attended about a year ago an event celebrating 30 years of ERCs, and a lot of our center directors and their students were there with demonstrations to show Congress. It was held in the, on the Hill, and so a lot of congressmen came by, and that was just a very good way to share with the other branch of government that is so important, that gives us our funding, what it is that the centers do. It's just most impressive. As I think just about everybody here knows, one of my predecessors at NSF, Eric Block, led the creation of the ERC program, and I remember when he did that. That was a big deal. That was a new thing for the agency, and look what it's yielded. I mean, just so much over those 30 years. The program that he originally conceived was intended to bring industry, academia, and government together to produce advances in engineering, innovative technologies, and effective solutions that translate into valuable industry-ready products and services. And by any measure, the ERCs have delivered on that. NSF has estimated through various reports, and I actually, being a scientist, I checked to make sure this was true, They have estimated that the economic value of ERC-originated products and processes is in the tens of billions of dollars. It's actually, if you want details on that statistic, you can ask Pramod, who has dug up the reports for me. That figure does not even include the enormous benefits of those products, which have improved health and safety, boosted industrial productivity, and enhanced environmental protection for our nation and the world at large. While applauding the many successes of the ERCs, we're deeply aware that the world has changed a lot over the last 30 years. I mean, just one thing, think of the internet and all that it's offered, or 3D printing. And I think a few of you from Texas know that the first 3D printing grant, the first, Engineer Zero, as I call him, is at the University of Texas at Austin, proposed to do a 3D printing experiment that people thought was kind of crazy, but he didn't ask for very much money. So, and that led to what we see today, absolutely amazing. And that's why I just keep coming back to the wonderful notion that NSF is where discoveries and discoverers begin. And recently, Eric Schmidt, of course, chairman of the board and former CEO of Google, said that to a big public gathering that NSF is at the basis of where everything that's new and creative has been developed. Some quote like that, which we try to use a lot. A critical component of this study is the valuable expertise from the front lines of engineering research, education, and innovation. So we are having this gathering, and delayed as it is, but to ask for your help in developing a vision and high-level strategic recommendation or set of recommendations for the future of NSF-supported center-scale multidisciplinary engineering research. As envisioned, the study is going to be forward-looking, focusing on the forces that are likely to shape engineering research and education. NSF is very much about the interconnection of research and education and technological innovation. And of course, we want to hear from you about the associated challenges and opportunities you see for the future of center-based engineering research. We want to ask you to look 20 to 30 years into the future and help us develop inspiring vision for center-scale research in engineering over that time frame. And we know that engineering is interconnected globally, of course, and I know we have some global participants here. Welcome back to the U.S., Jean-Lou. We're just very pleased to get that perspective, too, of what is happening globally that demands a different way of working together. We want to hear your thoughts on the most promising models and approaches for multidisciplinary engineering research that can successfully address those challenges and opportunities. Let me pause for a minute on multidisciplinary. It's called by many different things. A new word that we hear used a lot is convergence. And that is just such an important way of thinking. How does engineering and physics and biology and the social and behavioral and economic sciences and, of course, computing and information science, how do they all work together to drive towards new solutions, new ways of thinking, new kinds of innovation? And so you're going to hear the agency, and of course at our universities already, much more conversation about conversions. That means getting out of our stovepipes, getting out of the silos that we are constantly creating. And Dan Moat, where's Dan? Right in front of me, reminded me again this morning of how we talk a lot about breaking out of our silos, but we have a tendency then to fall back and create new ones. So that's a subject really worth discussing, and how do we constantly keep ourselves, so this tension of pulling and then collapsing back into silos. How do we break that tension? Existing ERCs may be used as prominent examples or cases in the study, but the intent is not to evaluate them, other processes for that. We hope you'll draw upon models of large-scale multidisciplinary engineering research in the U.S. and other parts of the world to help position NSF strategically to make an impact. That's our goal. So we have some key questions, 4 key questions that may help you frame your deliberations. The first one is what models might most effectively enable breakthrough multidisciplinary engineering research and discoveries that require center-scale investment, considering the convergence of physical sciences, engineering, the life sciences, and social sciences. So the models to effectively enable those breakthroughs through convergence. Number 2, what educational models of center-based engineering research programs are best suited to create a more diverse, internationally aware, and flexible talent pool that is capable of addressing complex real-world problems? This is not an academic notion for the National Science Foundation. Not only do we fund education, namely students at the graduate and also undergraduate level through ERCs, but we fund them in everything we do at the agency, and there's a huge national conversation going on now about what's the future of graduate education. And how should, talk about, a constant model that we haven't really changed up in a very long time. So how can your study and what you're doing with ERCs actually affect a new model for how we think of graduate education more globally? Number 3, what academic industry practitioner partnership models might most effectively promote advances in use-inspired basic and translational research, accelerate technology commercialization, and strengthen the broader innovation ecosystem? So partnerships. I am presently going around the country talking with, for example, next week, the Silicon Valley CEO group, their annual meeting, and then some DOE labs about, I call the talk NSF++. It's putting partnerships to work, because the more I meet with Congress, and I do every week, just yesterday was on the Hill meeting with some of our senators, and every week we have our assistant directors like Pramod also going to the Hill and talking. We realize that people, our elected officials, are committed to science and engineering, but they are not committed to necessarily increasing our budget. Okay, so we're going to have to use that tried and true technique of leverage, of really effective partnerships. And the ERCs are a great opportunity for thinking about partnerships in new and different ways. Now, some of you, I went recently to Illinois to be part of their opening of the Poets ERC, and it's just very clear that they're bringing in the partners already. But how do you think about scaling up those partnerships so that they are broader? And we talked even earlier about global. And then finally, what metrics can be used to define successes and risks of such center programs? A question that we're often asked on the Hill and elsewhere is about the metrics of success. I mentioned a statistic about the value returned on the investment in ERCs. How can we perhaps ahead of time more simply quantify what that return on investment is looking like, okay? And another thought I'd like to share with you is the perceptive observation that Bill Gates made about how difficult it is to forecast the future in this era of accelerating scientific and technological change. And he said something interesting. He said, we'll always overestimate the change that will happen in 2 years and underestimate the change that will happen in 10 years. That's kind of a profound thought. His point is that visions of what can be accomplished in a decade tend to fall far short of what can actually be done. So again, I ask that you think broadly, think big picture, think way out of the box. Help us create a bold new paradigm for the ERC program, and we, NSF, will do its very best to fulfill your visions. So now let me turn the program back over to David and ask Pramod too, if he'll come up here. I don't know if this is on your program, but it's in my notes that we would answer any questions before I take off. Is that okay? Do we have time for that? Okay. Pramod, who's our leader here, thank you very much. Thank you and good luck.